Today, in this video, we will see bending stresses or flexural stresses concept. The stresses in the beam to resist bending moment is called as bending stresses. Consider one simply supported beam with one end pinned and other end roller. P load acting at middle of this beam. Due to this external load P, there is bending occurs in this beam, and due to this external load P, there is shear force and bending moment occurs inside this beam. And due to this bending moment, this beam bend, and top side of this beam, due to this bending moment, top side of this beam, compressive stresses develop, and bottom side tensile stresses develop. Why these compressive stresses and tensile stresses develop? These stresses develop to resist bending moment. For equilibrium of this beam, due to external load, there is bending moment generated in this beam, and for resisting this bending moment, compressive stresses and tensile stresses develops in this beam, and these the stresses induced in the beam to resist bending moment. Stresses, that means compressive stresses and bending stresses. And these stresses are denoted as sigma or F. And this bending stresses changes linearly from compression to tension zone. See, consider this XX section. This is cross section of this beam, XX section, rectangular section, cross section XX. This is neutral axis at middle of this rectangle, neutral axis. This is compressive zone. This is tension zone. This is sigma C, compressive stress. Bending stresses changes linearly from compression to tension. See, this bending stresses changes linearly from compression to tension zone. This is tensile stresses. See this curve, linear curve. Bending stresses changes linearly from compression to tension zone. Bending stresses or flexural stresses denoted as sigma or F, and this sigma or F is equal to M by Z. This capital M is moment of resistance, and this Z is sectional modulus. This sigma is bending stresses, this capital M is moment of resistance, this Z is sectional modulus, and sectional modulus is moment of inertia divided by Y. Y is distance between neutral axis to extreme fiber. Bending is the major concept used in the design of structural components. Example, beam and girder. The stresses induced in the beam to resist bending moment is called as bending stresses or flexural stresses, denoted as sigma or F, and is equal to moment of resistance upon moment of resistance section of modulus. Here, section of modulus. Thank you very much.